LangGraph's channel-based communication model enables actors to exchange data through typed channels, with each channel implementing specific update semantics to control value persistence and visibility. This artifact demonstrates how different channel types, EphemeralValue and LastValue, interact within a multi-node Pregel application, where actors subscribe to channels, transform data, and propagate results through a directed flow. We'll examine how two nodes are constructed using Node Builder, each configured to read from specific channels, apply transformations, and write to downstream channels, with the overall application orchestrated by a Pregel instance that defines the channel types and execution boundaries. The invocation with a single input will reveal how channel semantics influence data propagation across the node graph.
From LangGraph, channels import LastValue, EphemeralValue. From LangGraph, Pregel import Pregel, Node Builder. Node 1. Node Builder, subscribe only A. $x, x plus x. Write to B. Node 2. Node Builder, subscribe to B. $x, xb, xb. Write to C. App equals Pregel. Nodes node. Node 1, node 2, node 2. Channels equals A. EphemeralValue ester. B. LastValue ester. C. EphemeralValue ester. Input channels equals A. Output channels equals B. C. App invoke A. Foo.
This code demonstrates a multi-node data flow using LangGraph's Pregel runtime, showcasing how different channel types affect message passing between actors. The architecture consists of two nodes connected sequentially, where node 1 processes input from channel A and writes to channel B, while node 2 reads from B and writes to C. The key distinction lies in the channel configurations. A and C use EphemeralValue, meaning they only persist for the current step, while B uses LastValue, which retains the most recent value across steps. The execution follows Pregel's Bulk Synchronous Parallel model, where nodes execute in discrete steps based on channel subscriptions. When invoked with a foo, the runtime first executes node 1 subscribe to input channel A, which concatenates the input string and writes fafu to channel B. In the next step, node 2 executes because it subscribes to B, reading the value and producing fafu in channel C. The LastValue behavior of channel B ensures the value persists between steps, while the EphemeralValue channels and C demonstrate single-step lifetime semantics. This pattern highlights trade-offs in channel persistence. LastValue enables stateful processing across steps but consumes memory, while EphemeralValue is memory efficient but requires all dependent nodes to execute in the same step. The design choice here reflects a pipeline where intermediate results B need to persist between nodes, while input-output channels A, C are treated as transient endpoints. The explicit channel typing also provides compile time safety, preventing type mismatches in the data flow. Let's break it down.
From LangGraph, channels import LastValue, EphemeralValue.
Imports two channel types from LangGraph: LastValue for storing the most recent value in a channel, and EphemeralValue for temporary values that don't persist between graph execution steps. These are used to define how data flows between actors in a Pregel-based graph execution model.
From LangGraph, Pregel import Pregel, Node Builder.
Imports the Pregel class and Node Builder class from the LangGraph Pregel module, providing the core components for building and executing LangGraph applications using the Pregel runtime model.
Node Builder, subscribe only A.
Creates a Node Builder instance configured to only subscribe to channel A. This means the node will only be triggered when updates occur on channel A during the Pregel execution cycle.
$x, x plus x.
applies a lambda function that takes an input x and returns the sum of x with itself, effectively doubling the input value. This operation is chained using the do method, which executes the transformation on the data flowing through the channel or pipeline.
Write to B.
Writes data to channel B in the current Pregel execution step. This operation queues an update to the channel's value, which will be processed during the update phase of the current step. The actual channel value modification follows the channel's defined update function when the step completes.
Node Builder. Subscribe to B.
Creates a node builder instance and configures it to subscribe to a channel named B. This establishes a dependency where the node being built will receive updates from channel B during execution.
Lambda x, xb, xb.
Applies a lambda function that takes a dictionary input x and returns the sum of the value at key b with itself. This operation effectively doubles the value stored under the b key in the input dictionary.
Write to C.
Writes data to channel C in the current Pregel execution step. This operation queues an update to the channel's value, which will be processed during the update phase of the current step. The actual channel value modification occurs after all actors complete execution for this step.
App equals Pregel.
Creates an instance of the Pregel class and assigns it to the variable app. This initializes a LangGraph application runtime that will manage the execution of actors and channels following the Bulk Synchronous Parallel model. The instance is ready to be configured with specific actors and channels for the application.
Nodes node. Node 1, node 2, node 2.
Defines a dictionary named nodes that maps string keys, node 1, and node 2 to their corresponding node objects, node 1 and node 2. This creates a lookup structure where each node can be referenced by its string identifier.
EphemeralValue ester.
Declares a channel named with EphemeralValue ester as its value type, indicating this channel will store string values that are transient and only persist for the current step in the Pregel execution model. The EphemeralValue wrapper specifies that the channel's value won't carry over to subsequent steps unless explicitly updated.
B. LastValue ester.
Declares a channel named B that stores string values and uses LastValue as its update function, which keeps only the most recent value written to the channel.
C. EphemeralValue ester.
Declares a channel named C with EphemeralValue ester as its value type. This creates a channel that stores string values but doesn't persist them between graph executions, as indicated by the EphemeralValue wrapper. The channel will be used for communication between actors in the LangGraph application, with its value being updated and read during the graph's execution steps.
Input channels equals A.
Specifies that this component will receive input from a single channel named In LangGraph's Pregel model, this means the actor will only process data that arrives through channel A during execution steps. The parameter defines the input source for this particular node in the graph.
Output channels equals B. C.
Specifies that the output will be written to channels named B and C. This parameter defines the destination channels for the data produced by the operation, allowing the results to be routed to specific channels in the LangGraph application.
App invoke A. Foo.
Invokes the LangGraph application with a single input dictionary containing the key mapped to the value foo. This triggers the graph execution with the provided input data, following the Pregel runtime's Bulk Synchronous Parallel processing model. The method will run the graph until completion or until a termination condition is met, processing the input through the configured actors and channels. This implementation showcases LangGraph's channel-based communication model in action, where the choice between EphemeralValue and LastValue channels directly impacts data flow persistence. The two-node pipeline demonstrates how Node 1 processes input from the ephemeral channel, doubles it, and writes to the persistent channel B using LastValue. This ensures the transformed value remains available for Node 2 in the subsequent execution step, where it's read, doubled again, and written to the ephemeral output channel C. The design highlights a key trade-off. LastValue enables stateful processing across steps, but requires memory retention, while EphemeralValue optimizes for single-step operations. The Pregel runtime orchestrates this flow, executing nodes in discrete steps based on channel subscriptions, with the channel types dictating whether values persist between steps or vanish immediately. This pattern effectively balances memory efficiency with the need for intermediate state retention in multi-step data processing pipelines.
The node shovels data into ephemeral channels, but the graph spits back infinite food.